we are going to see about the working of varistor and thermistor. So these two topics comes in the first unit, that is semiconductors and diodes of subject analog electronics. So in this session 5, we are going to see about varistor, thermistor, working of varistor, working of thermistor and application of the varistor and thermistor. Before going to this session 5, let me have a look on previous session what we studied. So the first thing we studied in the previous class was diode. So this diode is a PNP combination of P-type and N-type semiconductor which is having only one junction. This diode conducts in the forward biased condition. So that is about the diode. Next is our VI characteristics of diode. In this VI characteristics, we saw forward biased characteristics and reversed biased characteristics. From that, we are able to understand how this graph has been plotted for VI characteristics. This diode conducts in the forward biased condition. Next, we saw about application of diode. So normally the diode is used for the rectification purpose. So all these things we studied in the previous session. Next, coming to the types of diode. In the types of diode, we saw different types of diode. So the different types of diodes are Schottky diode, varistor diode, thermistor, step recovery diode, light emitting diode, Zener diode. All these are the different types of diodes. So all these things we have studied in the previous session. And again in the previous session we have studied about Zener diode. So this Zener diode is similar to an ordinary PN junction diode, but the Zener diode is heavily doped and the depletion layer it is very thin in case of a Zener diode. So next coming to the VI characteristics of Zener diode. In this VI characteristics, that is voltage ampere characteristic, here also we have two characteristics. One is forward bias characteristics, other is reverse bias characteristics. In the forward biased characteristics, it is similar to normal PN junction diode. In the Zener diode has a reverse biased characteristics, that is the characteristics where the diode is operating. There the current increases sharply and the voltage is constant, and that region of operation we'll call it as breakdown region. Normally Zener diode is operated in the reversed biased condition. Next, we saw Zener diode as an voltage regulator. So, the application of Zener diode is the voltage regulator. So, the working of this voltage regulator we saw in the previous session. How the Zener diode works as a voltage regulator, maintaining the voltage constant. That is, output voltage constant, irrespective of input changes in the input or changes in the load current, the output voltage will be constant. So by using this Zener diode. In the last class we saw the application of Zener diode also in the previous class. So the applications, it is normally used as an voltage regulator, surge suppressors, and then peak clippers and some switching application. This Zener diode is used. So all these things we have studied in the previous session. Next, coming to the session 7, we are going to study about varistor, thermistor, working of varistor, working of thermistor, and application of varistor and application of thermistor. Okay, let me start with the varistor now. So varistor is a variable resistor, and this varistor is a non-linear device. This varistor is a non-linear device and it is also called as a variable resistor. Here the resistance drops as voltage increases. This is also called as an voltage dependent resistor because the resistance is inversely proportional to the voltage. It is applied voltage. Hence, this is called as an voltage dependent resistor. The resistance is inversely proportional to the applied voltage. Here you can see this is the symbol of the varistor. So this is also a standard symbol of the varistor. You can see this is similar to a resistor, only thing it is variable. So this is the symbol of the varistor. So this is about the varistor. Next, moving on to symbol and characteristics. So we saw the varistor is an resistor which is variable. So that we call it as a varistor. So this is also a symbol where two diodes are connected back to back. So in case of a varistor, the symbol, so you can see here it is connected back to back. From this characteristics, you can see that the resistance drops and the volt up when the voltage is applied. So this is the static resistance curve. Resistance versus voltage. Voltage drops when the resistance drops when the voltage is applied. Next, working of varistor. In this working of varistor, when the power lines when the power lines or the transients or the lightning causes, that is when the transients exits or the lightning exists, where lightning exists into an AC voltage, our electronic equipment gets damaged. To avoid this damages, we are using this varistor. We are using this varistor. Varistor is connected between the supply line voltage and the transformer. It is connected in between that. This varistor is also called as a transient suppressor because it suppresses the power line transients. Hence, this is called as a transient suppressor. Okay, so coming to the working of this one, when the surge voltage is less than the clamping voltage of the varistor, that is, when the surge voltage, that is the lightning voltage, is less than the clamping voltage of the varistor, it offers extremely high resistance. Okay, so but when the surge voltage exceeds the clamping voltage, when the surge voltage is more than the clamping voltage of the varistor, the resistance of the varistor decreases rapidly, and this directs the fault current through the varistor by passing through the circuit to be protected. Hence, surge voltage suppression can be achieved. In this way, we can protect our electronic devices. So this is the working of the varistor. In this way, by connecting varistor in between the supply voltage and the transformer, we can protect our electronic devices. Next, coming to the application of varistor. So normally varistor is used in surge protected power adapters, telephone and communication lines, power supplies, electronics equipment protection, and it is used in automotive electronics, and it is also used in industrial high energy AC line protection. This varistor is used. These are some application of the varistor. Next, moving on to thermistor. So this thermistor is a one type of diode. So this thermistor is a combination of thermal and a resistor. Thermal, this is also called as a thermal resistor. This is thermally sensitive resistor. Is also called as temperature sensing element. Here, resistance is dependent on the temperature. That is, a large change in resistance proportional to a small change in the temperature. Here the operating range is minus 100 to plus 300 degree to 300 degree. This is the operating range of the thermistor. So the thermistor means it is a resistance dependent on temperature. That is, a large change in resistance proportional to the small change in the temperature. So this is the symbol of the thermistor. Next, these are the different types of thermistor which are available in the market. So there is an beads thermistor, disc thermistor, glass probe thermistor, special probe assembly thermistor, washer thermistor, specially mounted bead ring thermistor. These are some types of thermistors available in the market. Next, moving on to classification of thermistor. In this classification, we have two. First one is negative temperature coefficient. Second one is positive temperature coefficient. So this negative temperature coefficient is also called as NTC. NTC. Positive temperature coefficient is also called as PTC. So now let me know what is this NTC now. In NTC means the temperature increases, the resistance decreases. Whereas when the resistance decreases, the temperature going to increase. This type of characteristics exhibits in the negative temperature coefficient. Whereas in the positive temperature coefficient, as the temperature increases, the resistance also increases. When the resistance increases, the temperature also increases. This type of characteristics exhibits in the positive temperature coefficient. The example for this positive temperature coefficient is fuse. Here you can see the graph here, the resistance versus temperature. This is for positive temperature coefficient. This is for negative temperature coefficient. Next, moving on to working of a thermistor. The working of thermistor is explained with a small example by taking the fire alarm circuit. In this fire alarm circuit, we are using the thermistor for switching on the transistor. Switching on the transistor. Here it is used for the fire detection. This is one of the example for fire detection using thermistor. As shown in the figure, you can see here this is the thermistor and this is the resistor R1, diode D1 is connected, capacitor C1 and resistance R2 and one transistor, and this is the buzzer, and we are using the thermistor here. This thermistor is used for the fire detection. Whenever there is a fire, this thermistor gets sensed and gives the signal to the transistor. This transistor makes the buzzer to switch on. So let me study the working of thermistor here. Here the resistance R1, this resistance R1 and this thermistor, these two forms a potential divider network to drive this transistor. The semiconductor material used for the thermistor are sensitive to the variation in the temperature. The transistor is switched on by the voltage drop to the resistor R1. So this transistor is on when, by considering the voltage drop of resistor R1. At normal temperature, the voltage drop across the resistor R1 is low and hence the transistor is in the off condition. That is, under normal condition, that is no fire, there is no much temperature, normal temperature, the resistance across the resistor R1 is low, hence the transistor will be in off condition. When the temperature is high, the resistance of the temperature gets decreased. When the temperature gets decreased, so at the thermistor, so the voltage drop across the resistor R1 increases. So when this resistance drop increases, this conducts the transistor on. So this transistor is on. This makes the current to flow through the buzzer, which gives an alarm in the buzzer. Here, diode is used for enabling unidirectional conduction. To conduct only in one direction, this diode has been used. And the capacitor has been used here, that is capacitor C1. Capacitor C1 is used for suppressing the transients from the thermistor. So this is the working of the thermistor. Thermistor used for the fire protection by using the alarm. Next, coming to the application of thermistor. So let me see one by one the application here. The first one is current limiting devices. It is used as a current limiting devices for motor protection. Here you can see here a motor has been used. This is the motor. So here we are using a positive temperature coefficient thermistor in order to protect the motor. Next, you can see here it is used in the resistance thermometers. Resistance thermometers for the measurement of very high temperatures. As in thermometers, this has been used. Next, it is used in automotive applications in cars, motorcycle. So this has been used here. Next, it is used in level detectors, liquid level detectors. You can see here to know the level of the liquid, this thermistor is used. Next, let me have a revision on this one. So, thermistor is a dash. So, thermistor is a thermal resistor. Okay, the answer for the first question is thermal resistor. Second question is, which of the following is a negative temperature coefficient of resistance? So thermistor exhibits a negative temperature coefficient of resistance. Okay. So the answer is negative temperature coefficient. The third question is, the resistance decreases with increase in temperature exhibits in dash thermistor. We studied the characteristics there, positive temperature coefficient and negative temperature coefficient. The negative temperature coefficient temperature increases, the resistance decreases. So in case of a negative temperature coefficient, the resistance decreases and the temperature increases. The answer for the third question is negative temperature coefficient. Coming to the next question, generally the resistance of a negative temperature coefficient thermistor decreases exponentially with an increase in the temperature. This exhibits in the negative temperature coefficient. That is, as the resistance decreases, our temperature increases. That is, the answer is exponentially with an increase in the temperature. Next, come to the fifth question. The, the fifth question is, thermistor can be used. So thermistor can be used as an current limiting device, heating element and resistance thermometers. So the answer for the fifth question is as a current limiting device, heating element and resistance thermometer. Next, coming to the sixth question, that is main disadvantage of a thermistor. The main disadvantage of a thermistor is that it is having a non-linear output, slow response time, and it is having limited temperature range. So that is a disadvantage of the thermistor. A varistor is a dash. A varistor is an voltage dependent resistor. The answer is VDR, voltage dependent resistor. Next question is, the resistance of varistor is inversely proportional to the dash. Always the resistance of a varistor is inversely proportional to the voltage. So this we have studied the static characteristics. The answer for the eighth question is voltage. Next, coming to the ninth question, varistor is used as. Normally, varistor is used as surge protected power adapters and it is used in telephone and communication lines for the protection purpose. The answer for the 10th question is surge protected power adapters telephone and communication lines. Telephone line. So this is about the varistors and thermistors. With this, the unit 1 is completed. So let me have a quick revision on this entire chapter, semiconductors and diode. So at in the session 1 we started with conductors, insulators and semiconductors. We saw the energy band diagrams. So now let me see what is this conductors now. So conductors is nothing but the number of valence electron of an atom is less than 4, that we'll call it as an conductors. Example for the conductors is copper, aluminium and zinc. Next is a semiconductor. In semiconductor, the number of valence electron of an atom is 4. The material has both conductor and insulator properties. Example, carbon, silicon and germanium. Next, moving on to insulator, the number of valence electron of an atom is more than 4. The material is usually a non-metal and then it is called as an insulator. Example for insulators are nitrogen, sulfur and neon. So all these things we studied. Next, coming to the energy band diagram. Energy band diagram for conductors, insulators and semiconductors along with the diagram we have studied in the beginning of this session. This energy band diagram for a conductor, the material in which the conduction band and valence band overlap each other. This overlapping indicates a large number of electrons available for conduction. So that is the conductors. Next is coming to the insulators. In insulators, there is a small energy gap between the conduction band and the valence band. Here as electrons, here uh, large electrons of energy is required to mix in an insulator. The conduction band and valence band insulator, there is a wide energy gap. In this wide energy gap, large amount of energy is required to free electrons by moving them from valence band to conduction band. In case of a semiconductor, the valence band and conduction band is separated by a small energy gap. So this is about the energy band diagram. Next, we saw the properties of semiconductors we have studied in the previous session. The properties of semiconductors are, this semiconductor exhibits a negative temperature coefficient of resistance, and the second thing is resistivity of semiconductor is less than that of an insulator but more than that of the conductor. So these are the properties of the semiconductor. After this, the semiconductors we saw the intrinsic and extrinsic semiconductor. So intrinsic semiconductors are the pure semiconductors. Example, silicon and germanium. Extrinsic semiconductors are adding some impurities to the pure semiconductor is called as extrinsic semiconductor. This extensive semiconductors again classified as N-type semiconductors and P-type semiconductor. N-type semiconductor means when a small amount of pentavalent impurity is added to a pure semiconductor, we'll call it as N-type semiconductor. The pentavalent impurity is arsenic is added. Next, a p-type semiconductor. When a small amount of trivalent impurity is added to a pure semiconductor, we'll get the p-type semiconductor. The trivalent impurity used is gallium here. So this is about the intrinsic semiconductor, extrinsic semiconductor. Extrinsic is again classified as N-type and p-type semiconductors. So all these things we studied in the previous session. In the N-type semiconductor, majority charge carriers are the holes, electrons, and minority charge carriers are the holes. In a P-type semiconductor, majority charge carriers are holes, minority charge carriers are electrons. These are the properties of semiconductor. Next, we started with the diode. Diode is a combination of p-type and n-type semiconductor which is having one p-n junction. Next we have studied VI characteristics of diode. In this VI characteristics, we studied about forward biased characteristics and reversed biased characteristics. The diode conducts in the forward biased characteristics. In reversed biased characteristics, a small leakage current will flow. If we increase the current there, the diode gets damaged in a reversed biased condition. And then we studied the application of diode. Normally diode is used for the rectification purpose. Next we started with the Zener diode. So Zener diode is similar to normal PN junction diode, but it is heavily doped. The depletion layer in case of a Zener diode is very thin. This Zener diode conducts in both forward bias and reversed biased condition, but in reversed biased condition without damaging or destroying the Zener diode, it will be safely operated. So next, the application of Zener diode. Zener diode is normally used as an voltage regulator. So in the previous session, we have studied about Zener diode as an voltage regulator. So where the voltage is constant irrespective of changes in the voltage, input voltage or the load current can be increased or decreased. The output voltage is constant. Next, in the previous class, we have studied about the working of varistor and thermistor. So varistor is a combination of resistor and the varistor is a variable resistor, and this is also called as an voltage dependent resistor. And thermistor is a combination of thermal and resistor that will give the thermal resistor, just you have studied in the previous session. This is entirely about this chapter, that is semiconductors and diodes. Thank you. So these are certain reference websites. You can see this semiconductors and diodes details. Thank you.